Hello to all my students, parents, everybody, the whole world. Yeah, we're online now, so shout out to the entire world. Hope everybody gets a chance to learn a little something. We're going to start off talking about stars. All right, these notes are on stars. Now, if you're in my class, we just finished talking about the sun. But to take it a step further, because we know that the sun is a star, we're going to talk about stars specifically. These notes are on stars. Let me remind you, because you're watching this online, you can pause this. So I'm going to go through this very fast, way faster than I do in class, but you can pause it so that you can go at your own speed. Here we go. So, first off, definition of a star is a huge, hot, glowing ball of gas. A star shines only because the process within a star produces huge amounts of energy that includes heat, light, and radiation. The question I have for you is, what is this process called? This process that produces all of this energy, what is this process called? Of course, you all know this answer. It's called nuclear fusion. Nuclear fusion. Don't you ever forget it. All right, but here's the definition just in case you need it down, and of course you need it. The process in which the nuclei of two or more atoms join to form a single larger nucleus. Got it? Now, in most stars, including our sun, hydrogen atoms crash together to form helium atoms. Don't get it confused. Don't think that hydrogen atoms are actually crashing into helium atoms and that's giving us energy. No. All right, the reason so much energy is given off is because it's almost a freak of nature. You got two hydrogen atoms traveling at the speed of light. They crash into each other and boom, transform into something totally different. A heavier, different atom called helium. That process gives off nuclear energy. And the nuclear energy is the light we get from the sun, the heat we get from the sun, as well as that bad radiation. Again, it's a nuclear reaction that's going on. This process, nuclear fusion, gives off an immense amount of energy. Got it? Hydrogen atoms crashing into helium atoms. Oh, I'm sorry. Crashing into other hydrogen atoms and actually forming helium atoms. Here we go. Let's talk about magnitude and the brightness of a star. Real easy definition. Magnitude, the brightness of a star. The question will be on the test, what term describes the brightness of a star? Your answer is, yes, magnitude. Magnitude. Moving on. Why are some stars blue and some stars red? In terms of temperature, the hottest stars are blue and the coolest stars are red. That's almost complete opposite to what we kind of associate with temperature here on Earth. I mean, if you go to turn on the sink, the blue knob is for the cool water and the red knob is for the hot water. That's how we operate here on Earth. But when we talk about stars, the coolest stars are actually red and the hottest stars are blue. Now, sometimes stars appear to be blue because of what we call blue shift, and they appear to be red because of red shift. We're not going to get deep into that, but that's, if you believe in a Big Bang Theory, some stars are moving away from us, that gives off a red color. Some stars are moving toward us, that gives off a blue color. That's called blue shift and red shift. But what I want you to know for the test is the hottest stars are blue and the coolest stars are what color? Yes, red. Moving on. All right. That's the end. Real quick. Stars, the notes on the stars is very fast. Make sure that you understand that information. Nuclear fusion, magnitude, why certain stars are different colors, so on and so on. All right. This is Mr. Guest, and I'm out.